Hello everyone. Algebra and geometry may seem like separate worlds, one abstract, the other visual, but they are deeply intertwined. Algebra gives us language and tools to explore patterns, while geometry gives us the shapes and structures to visualize them. One of the best bridges between the two, it is Pythagorean triplet. If you take three numbers 3, 4 and 5, they will satisfy classic equation of the right triangle. That is 3 square plus 4 square equal to 5 square. They don't just help us measure right angles. They connect algebraic identities to geometric truths. They play a key role in the fields from architecture to computer graphics, and remind us how beautifully numbers and shapes can dance together. Our aim is to explore Pythagorean triplet, primitive Pythagorean triplet, some important properties, and to be ready for the Olympiads and ISI CMI entrance exam. Please stay tuned till the end of this video. A Pythagorean triplet, this is going to be a set of three positive integers. Those three integers will take this form x, y and z. This is the set of three positive integers, but here we will be writing this in the form of order triplet. So throughout our discussion, I will be using this symbol for Pythagorean triplet. And these three integers, set of positive integers, they will satisfy the relation that x square plus y square equal to z square. And now in a right angle triangle, if they are the length of sides of these two legs, these are called legs of right angle triangle, and hypotenuse is z, then what does this one imply? If three numbers satisfying the relation that x square plus y square equal to z square, then we'll be getting a right angle triangle. We are able to construct a right angle triangle whose length of sides are xy and hypotenuse is z. Is the converse true? Converse is also true. That is what? If there is a right angle triangle whose length of sides are x, y and z, then this will imply that x square plus y square equal to z square. Okay? So converse is also true. Actually, that in geometry, this part you are getting algebra to geometry, isn't it? This is algebraic and this part is geometric. Here this part is what? This part is geometric and this part is algebraic. So this is the topic where we are going to discuss how algebra and geometry are related to each other. But in our discussion, mainly we will be discussing about these three numbers x, y and z obeying this property. So the theorem was in geometry. Now it is a huge resource for algebraic discussion. Okay, the very first example, if I take for this triangle, if we take the length of three sides of this triangle as 4, 3 and 5, then this is a right angle triangle. It is obeying the relation that 3 square plus 4 square equal to 5 square. Okay. Why? Because this is 9, 16 and this is 25. A relation in right angle triangle. Now it is matter of our discussion in today's I'll say that today's video session. Okay. Now if 3, 4, 5, these are three integers obeying the relation that 3 square plus 4 square equal to 5 square, and if you multiply two sides, suppose by 5 square, so 5 square into 3 square, 5 square into 4 square, 5 square into 5 square, 5 square. So this implies 15 square plus 20 square equal to 25 square. Okay. So now these are three triplets. It was 3, 4, 5. If it is a Pythagorean triplet, then 15, 20, 25 is also a Pythagorean triplet. But we'll name this one as primitive Pythagorean triplet. This we'll name as primitive Pythagorean triplet. And this one we'll name as just Pythagorean triplet. It is not primitive. Why? What's the difference? This is Pythagorean triplet. Because here, if you go by pairwise and as a whole, if you find the GCD between three numbers, that GCD between three numbers, how to write? You just use this symbol 3, 4, 5. This is 1. But here, GCD going to be 15, 20, 25. If you by now we'll be using this symbol for GCD, but here you write GCD of 3, 4, 5, 1. But here GCD of these three numbers 5. That's why we have named this one as primitive Pythagorean triplet, or simply PPT, and this one going to be just PT, Pythagorean triplet. Primitive Pythagorean triplet and Pythagorean triplet, this is the basic difference, that they are not pairwise primes. They have a GCD over there between 15, 20, even 20, 25, and for these three numbers GCD exists. So what do you say about Pythagorean triplet? Primitive Pythagorean triplet. A triplet is said to be Pythagorean triplet, a Pythagorean triplet, or you simply write just PT. A Pythagorean triplet is a PPT if the GCD of those three numbers is equal to 1. Keep this in your mind. In today's session, mainly we'll be discussing about the primitive Pythagorean triplet. The example of primitive Pythagorean triplet, we have taken 3, 4, 5. So if I now say that if x, y, z is a PT, I mean PPT, primitive Pythagorean triplet, then for k be a positive integer, kx, ky, kz is a PPT. No, is a PT only, simply a PT. It's a Pythagorean triplet. but this one primitive Pythagorean triplet. 3, 4, 5 is a Pythagorean triplet. No, primitive Pythagorean triplet. But if you multiply by say 2, 6, 8, 10, this is just a Pythagorean triplet. Okay? Now, we'll say that, we have seen that primitive Pythagorean triplet, their GCD will be 1. It's fine. But this I'd like to state as a property. Let us study some properties here. That is, if the property 1, if x, y, z be a primitive triplet, then x, y, z are pairwise prime to each other. How to prove this? If this is a primitive triplet, then what is true about this thing? Proof. Given that x, y, z equal to 1, it is given x, y, z 1 because primitive triplet. And you are going to prove that, say we are going to prove that, first we prove this, x, y equal to 1. From here directly, by now we will say that if x, y, z primitive triplet, then x, y, their GCD is 1. To prove this, but how to prove it here? Since we have to prove x, y, 1, let us go by contradiction. By contradiction, let GCD is not 1, where this D has to be greater than 1. This is the GCD between x and y. Then this will imply that, D divides x and D divides y. Okay? This is a very common observation. If there is a GCD, it must divide x and y. Now suppose there be a prime. Let P be a prime which divides D. Let P be a prime, and this symbol is used for divisibility, that P divides D will be writing this way, and we have written already in number theory, if you go through my other video, that we have done this way only. P divides D. This implies that P divides D. So let P be a prime and P divides D. What does this imply? D divides x, D divides y. So P divides x and P divides y. But if P divides their squares, then for a prime number, it must divide the square and it must divide the square. What does this imply? This will divide their sum also. P divides x square plus y square. So this will imply that x square plus y square is what? Since this one given, what does this imply? That x square plus y square equal to z square. Isn't it? So P divides x square plus y square. This implies P divides z square. For a prime number, you cannot give any counter example where P divides z square but P doesn't divide z. So this will imply that P divides z. But what you have assumed? What is given over there? but x, y, z equal to 1. It is given GCD between x among these three numbers is 1. But what have you got now? P is a common factor, but here what does this imply? P is a factor of x, P is a factor of y, P is a factor of z. So this will imply that P is a factor of x, y, z. Okay? So this is wrong. Which one wrong? This is not wrong. This is given. What we have assumed here, this is wrong. Therefore, x, y cannot have a common divisor. I mean GCD. X, y, their GCD cannot be equal to D. So this implies that GCD between x, y equal to 1. Now, if we have proved that GCD between x, y 1, similarly, we can prove that similarly yz1 and zx1. We can prove all this by all those similar steps. You should try. But here, now I am going to tell you another very interesting property of this PPT, I mean primitive Pythagorean triplet. That is what? If XYZ is a PPT, primitive Pythagorean triplet, then this is very important, very interesting. Then Z is odd and XY are of different parity. Different parity means one of them is odd. This implies that one is odd integer, and the other is even. And later on in my forthcoming video sessions, I'll show you how this will help you to solve ISI CMI problems very first, some Olympiad sums also. Okay, let us prove this first, that if XYZ is a PPT, then Z must be odd. Now, we have just seen that GCD among these three numbers will be 1 for a primitive Pythagorean triplet. So, what does this imply? We have seen that if this is 1, this implies that XY equal to 1. XY1 means this implies that XY do not have a common factor. XY do not have a common factor. It means XY together cannot be even. This implies that X and Y cannot be both even. You agree? These two cannot be both even. Can they be both odd? Let us take that. Let X and Y be of this form. X is equal to, I am using divisibility by 4. X is equal to 4k plus 1 and or 4k plus 3. Okay? If you go by divisibility by 4, then those three numbers, numbers can be expressed in the form 4k, 4k plus 1, 4k plus 2 and 4k plus 3. But 4k plus 2 is not odd. There is a common factor. 4k is also not odd. So which two are odd here? This one odd. This one is also odd. Okay? That's why I told that x and y, let x and y be 4k plus 1 or 4k plus 3. Then x square will be what form? X square is 4k plus 1 whole square. This you can write 8k square plus 8k plus 1, which is again going to be of this form, 4k, 2k plus 2 plus 1. Isn't it? This is of the form something like 4n plus 1. So x square is 4n plus 1. Similarly, for 4k plus 3 also, you can show that it is of 4k plus 3 form or 4k plus 1 form. So x square is of this form 4k, 4n plus 1. What about y square? Y square also you have to assume the same manner. It may be 4k plus 1 or 4k plus 3. So y square also going to be of the form 4n plus 1. If suppose you have taken this one 4k plus 1, then prove this. The square will be of this form. If you have taken 4k plus 3, what is its square? Suppose y or x, any one of them is 4k plus 3. Its square will be what? This is 16k square plus 24k plus 9. This is going to be 4 into 4k square, 6k plus 2 plus 1. This is of what form? 4n plus 1. Agree? Now, square of integer will be of this form. 4n plus 1, it may be 4n also. This is a very basic number theory concept. Square of integer may be 4n or 4n plus 1 form. So x square, y square, you got that form. Now what about z square? What does this imply about z square? Z square is x square plus y square. This is going to be a what form? If you take, say, this one you have taken 4n1, 4n2. This is going to be 4n1 plus 1 and 4n2 plus 1. So this is 4n1 plus n2 plus 2. n1 and n2 are positive integers. Number theory is the theory of positive integers at your level. So this is going to be again of the form 4k plus 2, or you write 4n plus 2. Why? Because n1 plus n2 is an integer. So this will be of the form 4n plus 2. So what you have got? Z square is not of the form 4k or 4k plus 1. Perfect squares will be of this form. Here you got z square equal to 4n plus 2. So this is not going to be a perfect square form. So xy cannot be both, am I clear? Xy cannot be both odd. So this implies that xy can't be both odd. So just one possibility is left. xy, one of them should be even, the other one must be odd. As a result, sum of even square and sum of odd square is always odd. Okay? So it is obvious that if x, y and z are Pythagorean triplet, then x and y, they are of opposite parity, and z is always odd. This part is always odd. This part may be even or odd. If it is even, then this part will be odd, this part even. This is a very useful property of Pythagorean triplet.